So, hello guys, I am Ranjan M. Oliveras, and for today we will be doing the experiment number 14, Synchronous Counter. This experiment focuses on a common synchronous IC counter, the 74LS160, which will be the IC that we will be using today. The IC is a decade counter. This means that it counts from 0 to 9 for a total of 10. Synchronous counting is achieved by having the clocks of the flip-flops internally clock simultaneously. The output changes at the same time when instructed by the count. Enable inputs and internal gating. The clock input trigger the flip-flops on the rising edge of the input clock. So, for this experiment, here is our diagram. As you can see here in the bottom left corner, we'll be using the 74LS160 IC, and for the simulation, the software we'll be using is Multisim. Now let's connect the circuits according to the diagram. First, let's connect the LEDs. So pin 14 goes to ion 4, pin 13 goes to ion 3, X, ion 2, then ion 1, lastly ion 5 to pin 15. Now that we've connected the LEDs to the designated pins, let's connect it to the ground. First, let's connect the pin 8 to the ground, followed by ion 4 directly connected to the ground. Let's connect each LEDs to each other so that they all are connected to the ground. Next is for the clock. Let's connect the clock pulse to the pin 2, then pin 16, which is VCC, to the 5 volts. Now for our switches, let's connect D1 to the clear, which is pin 1. Next, the D2 to the load. Then for D3, let's connect it to pin 7 and pin 10. Next, let's connect the positive side. Let's connect the input to the ground first. As you see here, it's connected to the ground, the top part of the SPDT switch. Next, here is for the positive side. Now that we've connected our circuits, let's try to simulate. First, let's switch D3 to logic high position and both D1 and D2 to logic low position. As you can see here, D3, to make it the logic high position, it is connected to VCC. So here, the bottom part, there it's on logic high position. Then for logic low position, that's to be connected to the ground. So here, D1 is connected to the ground, D2 is connected to the ground. Then let's on the power supply on it. See here, nothing's still happening. If we switch both D1 and D2 on, so you can see there's a pattern created by the LEDs in 4, in 3, then both of them are switched on. then transfer to in2, then in1, switch on. So there's a pattern in4, then in3, then back to in4, then goes to in2, then in4 again, in3, in4, then goes to in1, then in5 and in4 are both switched at the same time when in1 is on. So that is the pattern. Now, if we disconnect the jumper from the clock pulse generator, start to disconnect it. There are no more LEDs flashing. So let's try to put an logic low position. It's disconnected. So you can see the LED still remains the same. There are no patterns observed. So that's it for our experiment. I hope you guys learned. Thank you for watching.